So today we're going to look at how we graph cotangent, which is just the reciprocal of tangent. Okay. Here I've given you the tangent function and the cotangent, and we're just going to compare them. Being that cotangent is the reciprocal of tangent, anywhere where tangent would hit a y value of 0, so here at like 0 and pi and 2 pi, if we look at the cotangent function at those same points, we have vertical asymptotes. So whenever it's 0, we end up with like a 1 over 0 situation. So here are our vertical asymptotes. Now, these are also both the parent functions. So notice that, like, as tangent goes from negative pi over 2 to pi over 2, like one period of cotangent just goes from 0 to pi. So they have the same length. The period is still a length of just pi over b. Okay, and for the parent function, that b is 1. We find the increment the same way. It's still the period divided by 4. Only now, instead of having to go 2 to the right and 2 to the left, we're always going to graph them like this. We will start at h, and go 4 increments to the right, and you'll have vertical asymptotes at the beginning and ending of the period. Okay, and then the last thing that I'd like you to notice, here, let me shrink these down a little bit. The last thing that I'd like you to notice is here the parent function, these tangents are increasing, and the cotangent is decreasing. Okay, so with a positive a for cotangent, that causes the function to decrease, and a negative a will cause the function to increase. Okay, in this first example we have y equals 2 cotangent 5 pi x. Okay, so a is equal to 2. We don't have to factor out the b because the 5 pi x is the only thing in the parentheses. So b is 5 pi. The period is found by doing pi over b, so pi over 5 pi is 1/5. And then dividing that by 4 will give me the increment, or multiplying it by a fourth. So the increment is 1/20. We have the h is 0, and the k is 0. And looking back at this a of positive 2, will this function increase or decrease?
Decrease.
Yeah, we know it's going to decrease through. All right. So I'm going to draw my x-axis. We always start with h and then go 4 increments to the right. Now since h was 0, I can go ahead and make this my y-axis. Okay, so my h was 0. The increments were 1/20, so that's 1/20. 2/20 is 1/10. 3/20, and 4/20 gets me to that period of 1/5. So whereas tangent we would have had to go 2 to the right, 2 to the left, for cotangent we just start at h and go 4 to the right. Okay, and then the asymptotes are going to be at the beginning and ending of the period. So here at 0 and at 1/5. The graph didn't shift up or down, so I can just use my a of 2 to see that it's going to go here to 2 and negative 2. And then with these 3 points in the middle, I just make a decreasing function. Okay, so I hit top point at 1/20th 2, middle point at 1/10th 0, 3/20ths negative 2, and I've got my cotangent function. Alright, y equals negative 3 cotangent of 2/3x minus 4 pi plus 1. So my very first step, since I have a b inside the parentheses with another number, I need to factor out that 2/3. So y equals negative 3 cotangent of 2/3 times x minus, now to factor that out, that'd just be 4 pi divided by 2/3, so times 3/2. 12 pi over 2 is 6 pi plus 1. Okay, so now I'm ready to list all the things. A is negative 3. What does that let me know about the shape of this? It's going to increase because it's a negative a. Same thing. B is 2/3. So my period will be pi divided by 2/3, or pi times 3/2. So it's 3 pi over 2. Dividing that by 8, I have an increment of, by 4, gives me an increment of 3 pi over 8. We have an h of positive 6 pi and a k of positive 1. All right, now we listed everything that we need in order to graph it. Okay, so we always start with h. Not in blue. It's a graph. I want it in black. So I'm going to start with h and go 4 increments to the right. So my h was 6 pi. That's going to put my y-axis way back. So I'll just draw it over here. Okay. Now, the thing about this problem is that we have 6 pi but with an increment of 3 pi over 8. So I'm going to change 6 pi. I'm going to multiply by 8 over 8 to get 48 pi over 8. Because that's much easier to add 3 pi over 8 to. So adding, I get 51 pi over 8, 54 pi over 8, 57 pi over 8, and 60 pi over 8. And then I'm just going to take whichever ones can reduce and reduce them. So 51 pi over 8 doesn't reduce. 54 pi over 8 is 27 pi over 4. This 57 pi over 8 doesn't reduce. And 60 pi over 8 reduces to 15 pi over 2. And then we can just go back and erase these. Well, I was planning on erasing them, and then this thing messed up, so forgive me.
No.
Okay, now, where did the asymptotes go? Yeah, the asymptotes go at the beginning and ending of the period. So it's 6 pi and 15 pi over 2. Okay, with a k of positive 1, I know that this graph shifted up 1. And since a is 3, how high will it go? Up to 4 and down to negative 2. And this is probably the worst scaling that I've ever done. 1 is way further away than negative 2, but as long as we label, we're fine. This graph is going to increase since it's a negative cotangent. So I just go to my middle 3 points. 51 pi over 8, negative 2. Careful not to put the next one on the x-axis. It needs to go 27 pi over 4 and 1. 57 pi over 8, 4. Draw my curve through. And that's the cotangent function.